Happy Friday, everyone. This is our last section in Unit 9. We are going to be discussing oblique or slant asymptotes. This is just another thing that can happen. Remember, I kind of indicated yesterday in the video that there are other things that can happen, and I'm by no means hitting all the different types of graphs that you can get for a rational function, but these are things that occur. And so today's topic is oblique or slant asymptotes. They occur when the power in the numerator is one more than the power in the denominator. And what happens is when you take that limit as x approaches infinity, you'll end up having, for the end behavior, you'll end up having a different end behavior on the positive infinity side and on the negative infinity side. And it creates something called this sort of diagonal or slant asymptote. And so this graph will end up having these curved things, sort of like the regular normal function that we looked at, but it's going to have the end behavior is going to look a little bit different. So don't worry about it too much. You're going to end up going back to an Algebra 2 topic, long dividing, rational functions, and so we'll review that a little bit. But the rest of the process is pretty much the same. So you're still going to factor if possible, and cancel if you can to find some holes in your graph. Those can still occur. The next thing you're going to do is find your x-intercept. Remember, that's setting the numerator equal to 0. And you'll still go ahead and find your y-intercept by replacing x with 0. You'll still find your vertical asymptotes by setting the denominator equal to 0. And then lastly, you will not have a horizontal asymptote. And so what you're going to have to do to find your oblique asymptote, is long divide. So when we set up our long division, we will do the numerator, x squared minus x minus 2, divided by the denominator, x minus 4. I'll get to that shortly. We'll go through that process shortly. I just want to go through and do the rest of the problem, find all of those other things, just to remind you it's just the same. And the process only changes down here when we get to that last step. And again, if you get here and you forget that you need to look for this, the power in the numerator is one more than the power in the denominator, you're going to find the issue when you start to take your limit as x approaches infinity, because this ends up being top heavy and you'll end up with a limit that approaches infinity. And that makes for a difficult horizontal, or actually what I should say is no horizontal asymptote. Okay, so again, let's just kind of go through. I'm going to start by factoring, so I end up with x minus 2 x plus 1 over x minus 4. I can't cancel anything out, and so I don't have any holes in this function, so no holes. Then I'll move on to my next step, and that is setting the numerator equal to 0. So x minus 2 equals 0, and x plus 1 equals 0. That's at x equals 2 and x equals negative 1. So I have those holes at, or not holes, x-intercepts. Geesh, you can tell it's early morning on Friday for me. X-intercepts at 2, 0, and at negative 1, 0. My next move then is to find my y-intercept by replacing all my x's with 0. And so when I do that, change color so it stands out a little bit. This one is y-intercept. I will do 0 minus 2 over 0 plus 1, or times 0 plus 1 over 0 minus 4. Holy smokes. And when I do the math there, I get negative 2 over negative 4, or 1/2. So I'll have that point at 0, 1/2. Then I'll go ahead and do my vertical asymptote. Remember, vertical asymptote is when your denominator equals 0, so that is x minus 4 equals 0. That's at x equal to 4. I'm going to put all of those things together on the graph right now so that I have them. So I'm going to set my graph over to the side here. Make it draw right. Okay. I'm going to put all those things on there. I have my x-intercepts at 2 and -1. I have my y-intercept at 1/2. So I'll just approximate. Remember, this doesn't have to be perfectly beautiful. I have my vertical asymptote at 4. So that's going to go over here off to the side. All right. And now let's do the new stuff. Not real new, review stuff. We are going to long divide. So let's do a quick refresher on that. Keep in mind when you're long dividing, you have to always sort of look at the front term. So I'm thinking to myself, how am I going to make x look like x squared? And to do that, I'll have to multiply x times x. So I'll put the x up on the top. But this is a quantity, so I have to multiply the x to get the x squared. And then I also have to multiply the -4. So my next term is -4 times x minus 4x. Keep in mind, when you long divide, you actually multiply and subtract. So I have to take this whole thing here and subtract it. And so when I do that, remember, this changes the sign on both of these things. So this becomes plus -x squared minus -4x. So then that's plus 4x. So I'm subtracting the whole thing. And I know I'm kind of changing the color a lot or whatever, but I hope that sort of stands out and rings a bell. Multiply and subtract. So my whole goal is to get rid of that front term. And then I do -x plus 4x is 3x minus 2. And then I'll start again, and I want to figure out how to make x look like 3x. And so to do that, I would add 3 or multiply by positive 3. So I get 3x minus 12. Here's where it's different from what you've done in the past. Once I get here, I need to subtract this whole thing. So remember, that's going to be changing those signs. So this becomes plus -3x plus 12. I'm going to get rid of that front term. I'm down with 10 here, but I don't even care about that. That really doesn't even matter. The remainder makes no difference. This is what I'm interested in. This becomes my oblique asymptote. Just what I had to do to get rid of that front term, and I have my oblique asymptote. So this line is y equals x plus 3. So I'm just going to graph that like I would a normal line. This tells me where I start. My slope here is 1. So this is start at 3 on the x-axis, and then my slope goes up 1, right 1, up 1, right 1. So here's my best rendition of this. The thing you have to be a little bit careful of here is that because the slope changes, things like where your x and your y intercepts are, sometimes those can be very close to each other. So just kind of be aware of where you're putting things, okay? So there's my oblique asymptote. It came from that long division, what I got when I long divided. Now I can put the graph together just like I did any other graph. It's got to approach the asymptote. It's going to curve through and approach the asymptote. And so now I have these regions. My first one was obvious where it went. It was down in the lower left region. But then I have an upper left region, an upper right region, and a lower right region. Where do I put the rest of the graph? Just like we did before, if there is a double denominator, that's the only way, like where it repeats twice. If this had x minus 4, that would be the only way that I could have this going in the same direction on both sides. The other thing that you have to look for is, I know it can't be in this lower right portion because I would have to have an opening on the x-axis for it to cross, and I don't. It also can't be in the upper left portion because it would have to cross the y-axis again, and also it would fail to be a function. So the only remaining part for this to be is in this upper little area. And again, we're just doing a sketch, so you don't have to do perfect. I just know it's going to be a little swoopy thing that approaches the asymptotes. Okay, so not very new. Again, it's the same steps up until you get to that very last step, and then we're going to have to long divide. Just be aware. You know, like, how am I ever going to know? Just be aware. I'm telling you right now, look for it. If the power in the numerator is 1 more than the power in the denominator, you're going to have an oblique asymptote. If the power in the numerator is 2 more than in the denominator, then don't worry about it. We're not doing those. You're not going to see one of those. It'll be a different scenario that would happen. So I'm just showing you the ones that you're going to see, and just keep that in mind as you go through. Okay? So what I'd like you to do right now is take a few moments and pause the video and see if you can go through the next problem, keeping in mind that you are going to have to factor, cancel out any holes if possible, do your long division. All of that stuff is going to come into play. So I'd say pause the video for a moment, give yourself a few minutes, and then go back to the video. Okay, so I'm going to assume that you took a few moments to do that, to give it a try. And so now I'm going to go ahead and work through. My first move here is to factor. I'll factor out an x. This is x squared plus 3x plus 2 over x times x plus 4. This is x times x plus 2, x plus 1 over x times x plus 4. The x's are going to cancel out, so I have a whole at x equals 1. Move on to my next. Set the numerator, x plus 2 equals 0, x plus 1 equals 0. That gives me negative 2 and negative 1. So those are points negative 2, 0, negative 1, 0. Third move is to figure out my y-intercept by replacing all of my x's with 0. So I get 0 plus 2 times 0 plus 1 over 0 plus 4. I get 2 over 4, or 1/2. Fourth, my vertical asymptote. I'm going to set the denominator equal to 0, x equals negative 4. And then lastly, because the power on top is 1 more than the power on the bottom, I'm going to long divide. So I'm going to set this up. You can do it in two positions. You could do it with the x pulled out and use x squared plus 3x plus 2 over x plus 4, or you could do it with the original function like I always did the other asymptotes. Either way, it's going to come out to be the same thing. I'm going to do with the x pulled out just to make my math a little easier. X squared plus 3x plus 2 and x plus 4. So how do I make x look like x squared? I multiply it by x. That gives me x squared plus 4x. Change my signs. Negative x plus 2. How do I make x look like negative x? Minus 1. Multiply through. That's negative x minus 4. Change my signs. And add. I end up with the front terms crossing out exactly like I wanted, leaving me with a remainder of 6, which I don't care about. This is what I care about. I'm going to graph y equals x minus 1. So now I have everything that I need to put this graph together. I will start at the top and sketch my pieces in. I have, I don't want to, oh, I wrote this, I just realized this, I wrote this here, it's at x equals to 0, sorry about that. So I'm going to go ahead and put on my x-intercepts at negative 1 and negative 2, my y-intercept at 1/2. I'm going to sketch my vertical asymptote at negative 4, and my oblique asymptote is this line at y equals x minus 1. So I go down 1, and then up 1, right 1. So this line is going to come through in that fashion. And I realized that I made an error here after the fact. I'm like, what is going on? Well, that happens. This should be here and here. Oh my goodness, that is so. Those aren't there. Pretend those are gone. It happens. You don't always get it right. Notice that to me, I'm like, wait a second, something's wrong here. I put those in the wrong spot. It should have been at -2 and -1, and that haunted me later on because when I put this in, I was realizing this graph isn't going to work if I continue this way. So looking back, I see again my early morning mishaps. Sorry about that. So now I can graph the rest of my functions. So this has to cut through. Those points have to be connected. And then it can't be in the upper left because it would have to cross the axis again. It can't be in the lower right because it would have to cross the axis, and it would fail to be a function. So the only spot this can fit in here is this down bottom here area here. The only last thing I have to remember is that there's a hole there, so I'll put a hole on the function when x is 0. Okay? So hopefully you worked through that. Hopefully you worked through it better than I did. Let's move on to the next one because I want to show you a couple other things that can happen. Some of you may or may not be thinking, well, I remember learning synthetic division and I really liked it. It was easy, and can I do that? Actually, you can do that until you get to a problem like number 3. The power on top is 1 higher than the power on the bottom. But the problem is, when I long divide, I'm going to be dividing, I'm going to be trying to make 4x look like x squared. And in synthetic substitution, the process to do that is much more complicated than long division. So I highly recommend just doing the long division. As you saw in the previous 2 problems, it's pretty quick. So why don't you take a few moments again, pause the video, go ahead and find everything up to 5, and then we'll talk about 5. I'm going to work silently here. That's too silent for me. I can hardly stand it. I did my now zeros. Okay, so now I got through those first 4 processes. Hopefully you did the same. Hopefully you're joining back here. And let's talk about 5. Again, the power on top is 1 more than the power on the bottom, so I'm going to have an oblique asymptote. That means I'm in a long divide. I set the numerator in. I didn't have any holes, so I can't cancel anything out. I set the denominator out. This is where people get like a little nervous. How do I make 4x look like 1x squared? Well, to take a whole number and make it look like a smaller number, I'm going to have to multiply by a fraction. So to make 4x look like x squared, some of you might have already guessed it, I'll do 1/4 x. So 4 times 1/4 is 1, and x times x is x squared. Then 4 times 1/4 here would give me plus x. Again, keep in mind I multiply and subtract, so I'm going to change my signs. That leaves me with 6x plus 12. Okay, now this one's a little weird because I have to again try and figure out how am I going to make 4x look like 6x. What do I have to multiply 4 by to get 6? So off to the side, I'm going to go 4 times something equals 6. 4 times, I don't know, question mark. We'll put in whatever variable you want. That means that something must be 6/4 or reduces down to 3/2. So we will do plus 3/2. A bit weird, but we can graph that. We've graphed fractions before. It just is going to go somewhere between 1 and 2 when we graph it on the y-axis. And we're just approximating, so we don't have to think about it too terribly much. So 4x times 3/2 gives me 6x plus 4 times 3/2 is 6. Change my signs and subtract those out. I end up with 6, which I don't care about. This is what I care about. I'm going to graph that as y equals 1/4 x plus 3/2. All right. Get my sketch going on here. I will plot my on the right spot this time. -3 and -4 are my x-intercepts. My y-intercept is up here at +3. My vertical asymptote is at -1. And now I have to do this guy. I'm going to do that in a color again so it stands out. So 3/2 is up here a little bit. This one is at 3. So 1.5, that would be right in the middle of that. So there's that point there. And then I'm going to go up 1 over 4. So I'm going to try and make this be maybe a little higher than that. This would be down 1 over 4. So this point right here was at -4. So I want to try and approximate those as best I can and then get this so I don't end up on a line that I shouldn't end up on. And now I've got that asymptote in there, and I can go ahead and sketch my function. I'll do it, and maybe this will stand out. So I know it's got to come through and hit that point. Okay, that's my upper right. It can't be in the lower right because it can't cross these axes again. There's no spot where it crosses. There's no opening. And the other spot is here. It's going to be kind of a little quick change in there. Again, just a sketch, so don't worry about it too much. And so then that's the remaining portion of that graph. So this is why synthetic division doesn't always work. Okay. Again, if you want to take a few moments and set or pause the video and give the last one a try, please feel free to do so. Otherwise, I'm just going to work right through it, and then you can revisit when you're done. So our last one, we have our same process. I'm going to start by factoring x minus 4, x plus 2. Two numbers that multiply to be -8, add to be -2. On the bottom it's 2 times x minus 2. Nothing cancels, so again, no holes. Then I set my numerator equal to 0. Those are my zeros. Replace my x's with 0. And vertical asymptote 2 equals 0. That's never going to happen. X minus 2 equals 0. X equals 2. Now let's get into the long division portion. If the long division is still giving you a hard time, I would say try to, Google a review or something of how to long divide. I'll look for something, and if I find something, or if you need something, let me know, and I'll share a link with you. Otherwise, I'm sure you'd be able to find something on YouTube pretty easily. So unfactored form, I put it back in here. How do I make 2x look like x squared? That's definitely going to be 1/2 because 2 times 1/2 is 1. So I get my x squared minus 2x. I will change my signs. This ends up canceling, and canceling, so I end up with 0 minus 8. Well, this becomes my remainder, and remember on all of them that we did, we don't care about the remainder, all we care about is this. So this is sort of another interesting thing that happens where I end up with my oblique asymptote not having a y-intercept of 0 when I graph that line. So that means I'm going to start at 0 and then go up 1, right 2 from there. So again, I'll put everything together on my graph. My only request for you guys, again, is to be real careful about where you're putting things in position. You don't have to be too super careful. I know -2 is to the left of 0. I know +4 is more to the right of 0 than -2 is to the left of 0. The y-intercept is up 2. And then my vertical asymptote is right here at 2. This guy I have to be, again, a little bit careful with in terms of not stepping on any toes here in terms of where things are. So I start at 0. This is at 2, so I'm going to go up 1, right 2. There's going to be my next point, and then I'll sketch that in. Just take your time with it. If it hits on another point, you maybe did something wrong, go back and double check. But then you can put your graph together, approaching its asymptotes on each side. Again, it can't be in the lower left because it doesn't cross the y-axis down here, and it can't be in the upper right because it already crosses in the lower right, so I can't have another piece up there. So finish up your 9-3 homework. Your homework will be on Tuesday when you take your test. On Monday, we'll do a review. As always, if you have any questions, let me know. Have a great weekend.